All right, hi, my name is Alex Huckstep. I lead sales and business development for Digital Alloys. We've developed a new high-speed, low-cost metal printing technology called Joule Printing. Joule Printing is the fastest way to make the hardest parts. What the hell do we mean by hardest parts? Parts that are made from hard-to-process metals like titanium, Inconel, tool steel. Hard-to-make designs that are complex. Hard-to-source parts because of lead time, cost, supply chain risks. Quick background on the company. So the technology Joule Printing has been in development now for about 5 years. We formed the company about 2 years ago. Since then, we've raised $18 million in funding from investors including Khosla and strategics like Boeing and Lincoln Electric, who is the leader in welding technology. And we plan to commercialize the technology later this year. So why are people excited about 3D printing? Well, it has the ability to improve products through complex freedom of design, and it has the ability to save time and cost by eliminating tooling. But when you look at existing metal 3D printing technologies out there, they've barely made a dent in the massive $2 trillion metal manufacturing market. And we've talked to over 500 manufacturers now and asked them why that is. And the answers we consistently hear are, it's too slow, it's too expensive, and it's too complex to scale and integrate into production. So Joule Printing solves these challenges. Start the video here. Joule Printing solves these challenges by using off-the-shelf welding wire, which is great because it's low cost, it's ubiquitous, you can find it in virtually any metal. We touch that wire to the print plate like you see in the video, and then we push high current electricity through the wire, melting the tip of the wire into a bead of metal that we build up a complex part in. The physics is resistive heating. It's just like a coil in a toaster. And the beauty is that it's extremely fast. As you see here, this is a real-time video. It's very low cost because of the input cost of the wire and the speed of the process, and it's able to deliver really high-quality metal. As a point of reference, this bar that I'm holding here, which you also see printing, prints in about 7 minutes. It's about 1/4 of a kilogram. This takes about a day to print using standard existing powder bed technologies. It's rough on the surface, like a casting, but you cut just inside the surface and you get down to really smooth, dense, high-quality metal. And that metal is very strong. We've been able to demonstrate with aerospace companies that we're able to see comparable to wrought properties, stronger than cast properties right out of the printer. So it's exciting that this Joule Printing technology is compatible with virtually any metal, but we're launching with two metals into 2 strategic markets. So with titanium, we're starting by addressing machine components, high buy-to-fly machine components or forged components, where we've seen we can save up to half or more than half of the cost and the lead time in producing parts like this aerospace fuselage bracket. There are thousands of parts in every plane that are like this. And similarly, in automotive, we can save a lot of time and cost in tooling applications, where we can print H13 tool steel to rapidly build casting tools, stamping tools, molding tools, and many more applications. Here's a quick view of the printer. The build envelope's about a 16-inch cube. That's about the size of a beach ball. We can print parts up to that size. And our leadership team. We have a really strong bench, including a lot of expertise in machine design, quite a few MIT PhD metallurgists, a lot of 3D printing industry experience, and our CEO, Duncan McCallum, has successfully built two companies before joining Digital Alloys. Quick view of some of our early access customers. You can see a lot of aerospace, automotive, industrial customers, and of course, we're always looking for more strategic customers, partners, and investors, so please find me later. Thanks.